happy with the finish this tool's leaving on the inside of that bore. So we'll continue with this setup. We did have some clearancing issues where the end of the bar here was just rubbing on the bore here, on the upper area of the bore. So I've just taken the bar out, polished a little bit more off this area here, and it'll just give us enough clearance now to get all the way in full depth in the hole. So it's just something you've got to be wary of. What'll happen, it'll start pushing the bar away and you'll get a funny shaped hole. And just keep an eye on the major diameter of our taper. So its finished size is 700 thou. So we're 653. So just under 50 thou to come out. That's looking good. Let's have a preliminary check of our taper. So I'll just before we get too far, in case we've got to do any adjustments. But this will give us a good enough indication. And it feels really good, there's no play in that, it's wanting to get stuck. So that's got really good contact, pretty even all the way down. Camera probably won't pick that up. But yeah, no, it's nice even contact all the way down. So we'll continue boring to size. This will be our last cut through with the boring bar. We'll try and get a bit of cutting oil up there if we can. Okay, and I've slowed the lathe right down to 420 RPM. And we got 10 thou to go. Okay, let's see what that looks like. Yep, so really good finish, nice finish on that. So I'll give that a clean out and we'll do a check on our taper. Quick size check first. And we're 703, 702. 700 is the size for the major diameter. We just have to face a little whisker off the end there, as we still have a saw cut edge on the end. It's only a couple of thou we'll take off. So it's hard to get in there to see, but I would call that a very good result straight off the bar. No polishing or cleaning up yet, so no, good result. Okay, we'll have a bit of a check on our taper. I have a Morse taper number 2 shank here. I'll just put a little dab of bearing blue on it. It's just ordinary bearing blue. It's just a light smear on it. And as you might be able to see, we've got a contact running, the full length of this taper. So I think we've really hit our mark on this one. Now, I did have a reamer for a backup in case it was required. It's only a roughing reamer, it's not a finishing reamer. Just in case, like the minor diameter of the bore tended to go a bit small on me, as what happens sometimes. But no, not required. Well, of course we better make sure the part that's going to fit into it on the lathe is going to fit. Oh, and there it is. And it's stuck. Lucky we're taking it out. Alright, we'll move on to the, we'll cut it to length and we'll move on to the threading operations. Now we have to reset our compound slide angle around to cut our 55-degree British Standard Whitworth thread. So we're going to angle it 27 degrees off 90, or off straight across. And I can't use the degree scale marked here because we're just slightly off it. And quite frankly, I wouldn't use a degree scale to cut a small thread anyway. You can be too far out. It's very easy to get it wrong. So I'll use my bevel protractor, the old Morum right. I've got a block, straight edge up against the chuck, the face of the chuck, and the bevel protractor against the machined face of the compound slide. And then I can just tap the compound slide around until everything sits true, making sure you hold the bevel protractor level, not on the piss, because your angle will change. Dead level, that's how I do it. And tighten it down. So now to set the cutting edges of our tool square to the job, square, perpendicular, true to the job. Remember the previous video when I ground this tool up, I indicated the rear of the tool, so I knew the rear of the tool was dead perpendicular to the centre of the angle that the tool is cutting. Now makes for an easy setup. I can just square it up against the chuck like that. And nip it down. Now I know that tool is set perfect. If you don't have the luxury of a cutter grinder when you grind these tools, you've got to revert to these thread gauges. So these can be a bit of a pain in the arse, especially not too bad on a larger, if you're doing a larger size thread, but to get them dead lined up, it can be a bit of a mission, and you can be out a bit very easily on a very small thread. But larger thread's not a problem because you've got more area there to hold against your tool. So our tool is square, so what we do now is we'll set our lathe to cut 12 threads per inch. The idea of our part, we've already bored the size, so we'll take a test cut once we've set and verified our pitch. Right, let's take a scratch pass and we'll see how we get on. It's pretty difficult to get in there with a pitch gauge, but we'll try it. And we are cutting a left-hand thread, hence that's the direction why we've got the compound angled the way we have, because the rear of the tool is the leading edge of the tool. Now from the little bit I can see, it looks like we're cutting something resembling 12 TPI, so we're going to go for it. See how we're looking so far. Okay, we're halfway to depth and we're looking good. So we'll carry on. If you're watching that bar then, you would have seen a fair bit of deflection. See, I can deflect it like that with my finger. So I'll just take a few spring passes now, see if we can't get some of that out of it. Okay, we'll give that a try. That should be good. Bloody compressor always comes on when you don't want it to.